Welcome back. In this video, we'll consider a problem set for Green's theorem. It's going to be a four-part problem set, and we'll take each part as clearly as possible. It says evaluate the double integral of x plus y dx plus y minus x dy along a parabola, a straight line joining 2 points, straight lines from one point to another, and then from that new point to yet another point, and then the curve with two x and y values with the t coordinates given as needed. Now we would start this off with the parabola. In evaluating this integral, we notice first and foremost that we have been given the bounds on the x and the y side. So you have x from 1 to 4 and then y from 1 to 2. That has been given to us. So we can rewrite our start points and end points as necessary. So we can write our start point as 1, 1 based off the integral, and then we have our endpoint as 4, 2, right? So whatever we evaluate based off it would be within that constraint, right? And you would notice that the parameters that each of the questions have lie within that constraint as well. Now, the very first thing is let us assign a value or a variable to the integral, so we do not have to repeat it every single time. Yes. So now let us take the first one, which is along a parabola. Now, when we are evaluating along the parabola, we have y squared equal to x. The goal is to first and foremost try to unify the variables within the integral, which means either you rewrite the variables based off y or you write the variables based off x. Now, in this case, if we were to rewrite all the functions in terms of x, then it would mean that from this substitution y squared equal to x would have made y squared of the formula, would have had y equal to square root of x. Now, dealing with roots would of course make it necessary for you to deal with either the positive or negative values of x within the root. That can be avoided by simply making all of this in terms of y, which is just using the substitution x equal to y squared as it is. Now, all of the variables will change to y, and by extension, you would also have to write the integral variables dx in terms of the y as well. Now, if y squared is equal to x, then clearly dx, that's differentiating both sides implicitly, you'd have this to be 2y dy. So dx will be equal to 2y dy, which means you can make a substitution for x and you can also make a substitution for dx. Now, in this regard, since we have made this substitution, we can easily see that should we now decide to rewrite the integral, then the integral I would become the integral. Now, because we are all left with the terms of y, we'll be left with the coordinate values for y as well, which will be 1 to 2, right? 1 being equal to y being equal to 1 at the lower bound, and then y being equal to 2 at the upper bound. And then this inward will become y squared plus y, that's x plus y, x is y squared, and then dx is 2y dy, then plus y minus y squared dy. This is what we are going to have to work with here. Now we can expand and simplify. We see that I will be equal to, when we expand, the integral of 1 to 2, right, 2y cubed plus 2y squared plus y minus y squared dy. This is what we're going to expand into. So if we collect like terms, we'll have integral from 1 to 2, 2y cubed plus y squared plus y dy. And this just simplifies into a beautiful algebraic integration process. So by the process of integration, you'll have this to simply be y raised to the power of 4 divided by 2 plus y raised to the power of 3 divided by 3 plus y raised to the power of 2 divided by 2, all of which will be evaluated along the bounds. So that when you put in the upper bound, 2 raised to the power 4 is 16 divided by 2, that gives us 8, plus 8 over 3 plus 2 on the upper bound, and then minus the substitution of the lower bound, 1 over 2 plus 1 over 3 plus 1 over 2. So that, of course, if we collect like terms, add up together both sides of the subtraction sign, we're going to have on this side, we're going to have this to be 3 times 8, that gives you 24, plus 8, that gives you 32, plus 6, that gives you 38, over 3, minus, do the same thing on this side, right? LCM, of course, because half plus half gives us 1, so LCM can remain 3. So you have this to be 4 over 3 as necessary. So subtracting this, we'll have a final result to be 34 over 3. So I equals 34 over 3 when it is evaluated along the parabola y squared is equal to x. So this is very, very important because this shows how the evaluation along this parabola would look like. Now, the values of the integral will change based off the different parts to which we are evaluating the integral. So the value we have gotten now is the value when we evaluate along this particular parabola. Now, when we evaluate along a straight line, the results would be slightly different. So what would the result be? Let us look at that next.